Alright, so now let's go ahead and pull up our programmer calculator and try to convert some numbers back and forth. So on my machine, I'm going to open up the default calculator app that is pre-installed, and this is simply just called calculator. If you are on Windows or on Linux, please go ahead and do the exact same thing. You just have to open up your default calculator. You don't have to install anything. And right here, I'm going to go into View, and the type of the calculator right now is basic, but I'm going to change it to programmer like this. Again, you can do the same thing whether you're on Linux or Windows. Please refer to the setup videos to see exactly how we can do this on other operating systems. Alright, now that I have my programmer calculator, let me just zoom in a little bit. Now we see some interesting stuff around here. You can see right here at the top that I can see my displayed number, and here I've got this little toggle thing that I can change the base of the number that is being displayed. So if I want to put in a base 8 number, I select 8. If I want to put a base 10 number or a decimal number, I select this. Or if I want to put a hexadecimal number or base 16, I select this. And as you can see, as soon as I select base 16, I see that 0x symbol appeared right here. It doesn't mean 0 times 0. This is the symbol that we see in hexadecimal. So if I put in a number, you can see that I still have that symbol right here. Now also at the bottom here, you can see that I can display the binary of that number. So whatever I put here, whether base 10, base 8, or base 16, we're going to see the binary right here at the bottom. Now we haven't talked about this base 8. It's also called octal numeric system, but we haven't talked about it, and we're not going to really use them in this course. Now, based on what you've learned so far, I think you should now be able to also understand octal numeric system or base 8 numeric system. Again, it's just like other numeric systems, but now it's base 8, so we only have 8 characters. You can see as soon as I select it, I now have access to only 8 characters, starting from 0 up until 7, and I can't use these letters or 8 or 9. Octal numeric system is not really commonly used nowadays in computers. It used to be pretty common when computers first came out, and we used to divide our bits by 3. And right now it's only just used in Unix file permissions and a few other places, but I really have never seen them used anywhere except in Unix file permissions, such as file permissions in Linux or in Mac OS. But, well, it's something that you should now be able to understand as well. The point about this is that now each character represents 3 bits. So as I select 7, you can see here in the binary representation that I filled 3 of the bits. And if I put 7 again, you can see that I selected 3 more bits. So each character is 3 bits. Again, we've got this octal numeric system to help us deal with binary better, but we now rarely use them because we can just as easily use hexadecimal, and in hexadecimal we can now represent each character with only 4 bits, which is better to us. And right now we usually divide our bits by 4. So hexadecimal is pretty commonly used and octal is not that much used. And same thing if I select hexadecimal, as I put in the F character, you can see here in the binary representation that I am filling 4 bits by each hexadecimal character that I put in. Now we don't have something like that in decimal. If I select decimal and I keep putting 9, it's not like that I'm occupying 3 or 4 bits. It really doesn't matter. So sometimes I could be filling 3 bits or 4 bits. It's not something nice as all filled with 1. So that's why we've got the octal and hexadecimal, because it's much easier to deal with binary, and also octal is not really used. We always use hexadecimal, some rare cases also octal, but now that you understand these other numeric systems, understanding octal should be fairly easy for you. I think you should now understand it without us even needing to talk about them. Alright, so let me now put in a number, let's say 4, maybe 2, and then 7, okay? So this is the hexadecimal number that I put at the top, and again, as you can see here, I can see the binary number. So if my computer wants to save maybe this number, 1063, so if my computer wants to save this, it will save it in this format. So 01000010 and then 0 and then 111. Now, something that computers do is that you can specify how many bits you want to allocate to store a specific variable. For example, in C++, the int variable, the int type, integer type, might take 32 bits to save a number, or you can change it to 16 or 64. So in that case, if you, for example, want to only use 16-bit to represent a number, this bit right here, this would be your most significant bit, and this bit right here again would be your least significant bit. So it's something that you can do in programming. In JavaScript, you can't do that, but in general, you can do that. In this case, in my calculator, it's just allocating 64 bits for all the numbers that I can put here. And well, it's just something that I wanted to point out, that if you're saving variables, numbers in programming in your computer, in your memory, you always have to specify how many bits you want to allocate for that. But well, in JavaScript, that's automatically done for you and you don't have to care about it. Now again, if you want to convert numbers back and forth, you just put in the number and then you can now easily change them like this. So if I put 500 in decimal, and if I want to see that in hexadecimal, I just select 16 right here. So 500 in decimal equals 1F4 in hexadecimal. Again, these are exact same amounts. Doesn't mean that I'm now changing the core thing. It doesn't mean that I'm changing my amount. It's just the same thing, but now I'm using different ways to represent the exact same thing. For example, my MacBook, my battery percentage right now is 100%. Now this 100 right now is saved in my memory somewhere. So if I put in 100 in decimal, this binary number that you see here at the bottom, this is now stored right now in my memory of my machine somewhere. I don't know what location, but it is stored somewhere in my memory. If I take a look at the content of my memory, if I take a look at all these zeros and ones, and if I display that, I'm going to see this. But if I display the content of my memory, I'm going to see it in hexadecimal. So I'm going to see something like this. So I'm going to see somewhere in my memory 64. So if I try to maybe log my whole memory on my terminal, I'm going to see this 64 somewhere, which is the value of my battery percentage. And as you can see, if I change it, that number changes, but that doesn't mean that I now have another battery percentage, okay? Again, it's just the same exact thing, right? And also, let's play around with this most significant bit and least significant bit a little bit, so that you get a better sense about why that's the least significant and why that's the most significant. In this case, we're using 64 bits to represent our binary in my calculator, and you can also see the positions below the numbers. For example, here, this is bit with position 0, and you can see 0 appeared here at the bottom. Now this one is bit number 16, and its position is 15, because we started counting from 0, right? And now this top row here, it doesn't mean that it's another binary number or something like that. This is the exact same number. So these two rows are representing the exact same number. So we can just take this first row and display it right here before this first row. In that case, it will be a more natural number to look at, but well, it's going to be too long, so maybe that's why Apple decided to display it like this. But it's the same number. Here you can see that this is my most significant digit, which its position is 63. Okay, so here I've got 64 bits. Now if I just put in one number, maybe 57 in decimal, if I just flip this first bit over. Now, by the way, in my application, I can just flip bits over by just clicking on them. So if I find any bit and just click on it, I'm just flipping it over. So if it's 1, it becomes 1. If it's 0, it becomes 1. Now, let's say again that we have this 57. If I flip my first bit, my least significant digit, my least significant bit, I'm just changing my value by 1. Okay, as you can see right here. And if I change my third bit here, you can see that I'm changing it by another value, but it's still not that big. It's just by a few units. Now, if I change my 16th bit right here, you can see that it's more significant. The change that I'm seeing is now, it's not just a few units right now. I'm now having a drastically different number. It's now 32,000 by just changing this bit. And if I change my most significant bit, which is this one, you can see that now the number is really crazy. Okay, it's totally different from what we had before. The magnitude of change when I change this byte is drastically big. It's much bigger than all the other bytes that come before it. So that's why we call them most significant and least significant, because as you can see here, the change is really noticeable. Alright, so that's it about the calculator, that this is how we can easily convert numbers back and forth. With this in place, you also might not really need that table, because at any point, if you want to see the binary of a hexadecimal character, you can just put it here, for example, 8, and you can see that hexadecimal character. For example, 8 is 1 and then 0, 0, 0, and then B is this, 1 is this, 3 is this. So we can just easily put these numbers, and you don't even need that hexadecimal to binary table. So you can just use this calculator at any time. It's pre-installed on your operating system, and it's a very good tool. I use it a lot, and hopefully you also start to use it throughout this course. Now, there are also some other things around here, for example, 1's complement and 2's complement, and also we've got some logic gates right here, AND gates, XOR gates, NOR gates. We're not going to talk about these things in this course, and well, just in short, these are the things that would allow you to now do some operations on the binary. For example, add them together, or subtract them, or multiply them, divide them. And now this is how your CPU works. For example, if your CPU wants to add two numbers, well, they are just two binary numbers, it will just flip some of the bytes and then kind of add them together using some of the AND gates. Again, we're not going to talk about these things in the course, although it's one of my favorite topics, but we're not going to get into them. It's not really related to Node.js, although if you learn about them, for sure you're going to become a better software engineer because now you know how your CPU works. But if I want to teach a course on computer architecture, I'm going to need at least 40 hours. So again, we're not going to talk about these things in this course, but I just wanted to say that it's really good to keep this in mind so that one day in your career, the sooner the better, you can go ahead and learn about these things so that you know what exactly happens when you're executing code in your computer. How is your CPU dealing with that code? How is it talking to the memory and all that stuff? So it's really important learning about computer architecture. It's, again, one of the core computer science topics that it could help you a lot if you learn about them. But again, I just want to say that we're not going to use them in this course, but just keep that in mind that one day, if you get a chance, please go ahead and learn about these things. All right, so hopefully now you know how to easily convert numbers back and forth between these different numeric systems. And now that's it about this video, and I'll see you in the next one.